Associative mapping is used to store the address and content of the memory word. It can be considered as a part of your cache memory. Now, let us understand associative mapping. Now, what do you understand by associative? It is considered to be the most fastest, most flexible cache organization used as associative memory. The associative memory stores both the address and the data of the memory word. Now, why the address and data? Because it needs to map the data to the address bus simultaneously. It will also permit any location in cache to store and word from the main memory. Now, first, let us understand why address is required, why data is required, and why associative mapping helps to integrate address and data. Now, if you're transferring a data to a particular location, if the data does not contains any address, will the data get transferred successfully? It is not. Suppose you're writing a mail and after drafting a very beautiful mail, when it comes to two, you don't know to whom to send the mail. So will your mail go to that particular address or will it not go? It won't, because you're not specifying the address of the person who will be receiving that data. The address value of 15-bit is shown as 5-digit octal number, and it is corresponding 12-bit one. It is shown as your 4-digit octal number. Now see this. The CPU address is 15-bit. Then you have your register. Now the register contains the address and the data. The address is 01 000 02 777 22345, and the data that is being used for addressing is 3450 6710 and 1230 simultaneously. The CPU addresses of 15 bits is placed in the argument register, and the associative mapping used for matching the addresses. If the address is found, the corresponding 12-bit data is read and it is sent to the CPU. Now look at this case. If the address is found, it means that if the address is found into the cache memory, the address has been responded to the CPU and it is being sent to the CPU. If not, the main memory is accessed for the word. If the cache memory, now see this case, if the cache memory is full, in such cases an address data pair must be dispatched to make room for a pair that is needed and not presently in the cache. So you need to create a separate cache or an address data pair which can be mapped with the cache memory, and it must be displayed to make room for a pair that is needed and not presently into the cache memory. So it is not directly into the cache memory, but it is helping cache memory. It is retrieving the data from the cache memory so that it could give you the desired outputs and the result.